Monday was supposed to be New User Day, and so Ben had asked me to give a talk today, and then he said, well, why don't you give it on New User Day as well? But since most of you showed up for New User Day, I'm not going to bore you a second time with the same talk. And as a matter of fact, I'm not even really going to give a talk at all. I'm going to put up like 8 or 9 slides to motivate a discussion, and I'm hoping we can start more or less a free-for-all here. Almost like a panel, but with, I don't know, 200 panelists. So my first talk on Monday, if you were indeed here, you noticed that the cover slide had the usual caveat about the views and opinions expressed are those of the author and not the official position of the Department of Defense and all that stuff. You'll notice that my talk today doesn't even have that on the cover. And the reason is I'm not going to talk today about what I have done with government funding or am currently doing with government funding. I'm going to talk a little bit about some problems that we confront and some resources that are available for testing potential solutions to those problems. And then, like I say, hopefully we'll have more discussion than we will have presentation.
There we go.
Great.
Take it away. Sorry.
So, calling this brainstorming software-defined radio and small unmanned aerial systems. So this is one of the slides that you saw before if you were here Monday. This is a place where if you have an aircraft or possibly something other than an aircraft and you want to do some testing, and it's something that's intended to either fly, or I have no idea literally why they put that thing up there. You can bring it to Newport, New York, where the Air Force maintains what we call the Upside Down Air Force. And if you think about it, most of the antennas on aircraft are on the belly of the aircraft. I mean, there's a little bit of aircraft SATCOM, but most of the antennas are on the bottom. And aircraft spend most of their interesting time well away from the surface of the Earth. And so if you want to test antenna patterns and things like that, it's a bad idea to take your aircraft and elevate it up and still have its belly down, because now your belly-mounted antennas are way too close to the ground and patterns are all screwed up. So instead we flip them upside down there in Newport. And literally this is, I don't know, 5 miles, less than that as the crow flies from my house. I've driven by this almost every day of my life, well, since I started driving at any rate, and I've seen some really crazy stuff up on that tower. And the reason it's where it is that this is the top of a hill, and there's a top of another hill not far away, and the top of another hill not far away, and in between is a valley full of Amish dairy farmers. So we have a radio quiet environment, and you can bring your stuff there. Obviously, it requires a fair amount of advanced coordination. Okay. So this is a place where you can bring smaller aerial systems, and you can not only radiate as you can at that first location, you can also fly. And there are very, very few facilities within the United States where you can both radiate and fly, unless what you are radiating with is a type approved aeronautical mobile transmitter, right? This thing's got a runway. It can handle what are technically considered small UASs, in other words, 6 foot or less wingspan and 55 pounds and down. It probably can handle a little bit beyond that size limit. It can handle both fixed wing and rotary wing craft. And all of those numbers, P12, P11, those are pad 12, pad 11, pad 10. Each one of those is a concrete pad with one of those metal box military shelters with 220 volt power and a lot of fiber optic bandwidth that is home run to a central bunker from which you can run your experiments. And air conditioning, which for any of you who have worked in those shelters, you know how important that is. And there's a USERP in every one of those shelters. It's an N210 at the moment, and hopefully I'm going to get them upgraded to, you know, E312s on poles and things like that, but we'll see. Here's a place where, once again, you can both radiate and fly, and here you can bring big UAVs. We've had things flying out of here that are essentially manned aircraft that have had the man replaced with more or less a robot. So, you know, full-sized airplanes can take off on that runway. That runway is the former Griffiths Air Force Base, and that runway was actually one of the alternate landing sites for the space shuttle. So you can envision that it's pretty wide and pretty long and pretty straight, and you can fly some big stuff out of there. Now, what's going on there is work to try to integrate unmanned aerial systems into the National Airspace System. Now, the National Airspace System is divided up into different classes, A, B, C, et cetera, et cetera. So like Class A space is up around 18,000 feet and above, and that's where, you know, airlines spend their time once they climb out. Class G space is lower altitudes as long as you're far from a runway, a nuclear power plant, a military base, and a couple of other things. And there's various other classes. What we're supposed to be doing there is figuring out how you can get something to start at ground level and climb out, transition all the way to Class A airspace, and do so safely. Now, safe sharing into space by aircraft, there's really 4 classes of aircraft that, I mean, this is not an official classification, but my way of thinking about it, you've got manned aircraft, where there's a pilot and his butt is in a seat on the airframe. Then you've got human piloted aircraft where the piloting is being done remotely. And this is different, because the pilot cannot just look out the window and see stuff, right? He gets to see what is being presented to him on his video display or whatever. He doesn't feel the G-forces when he maneuvers. Then we've got semi-autonomous flight, where pretty much you program a series of GPS waypoints and the thing flies from waypoint to waypoint and then hovers or orbits or whatever at the waypoint for a while. And then, you know, ultimately we've got fully autonomous craft. How are we going to get these things to share the airspace safely? And the fundamental problem, to my mind, is just this. All human pilots basically got the same training. And so 2 human pilots operating in the same airspace, one's not going to surprise the other one. They each behave in the same fashion, right? Whereas a fully autonomous craft, it didn't go to those classes, and if we put it through those classes, it wouldn't internalize what was taught the same way our wetware does. And so my guess is, and this is merely a guess, if you put 2 artificial intelligences in the same airspace, they're probably not going to surprise each other either, because they're going to do perfectly rational and probably nearly optimal things. But put a human pilot and a computational intelligence in the same airspace, and probably one of them is going to surprise the other. And surprise is a really bad idea in aviation. So anyway, we got the NASA's Unmanned Traffic Management Conference coming up in November. Now, what the FAA is doing, and what NASA is doing, kind of assumes 3 things. It assumes mostly good intentions. It assumes that the human pilots, whether they are in the aircraft or on the ground with some kind of remote control rig, are trained. And it assumes that the systems that are operating the semi and fully autonomous craft are certified. And furthermore, that the communication systems and the navigation systems and so on that are being used by the human pilots are certified. So, what's the intersection of software-defined radio and unmanned aerial systems? Well, first off, the most obvious category of things you can do is use the software-defined radio to do something useful for UAS. So it starts out with characterizing the channel, right? Characterize the RF channel. The RF channel that a small UAS has is somewhat different from the channel that a large manned aircraft has. Because if you've ever dealt with antenna placement on an aircraft are like porcupines. They've got antennas sticking out of them all over the place. And each one of those antennas is pretty much in the near field of every other one of those antennas. And it's a nightmare, right? And at a lot of the higher frequencies, the aircraft skin is big enough to count as a ground plane or a reflector or a director or whatever. Whereas when you get into small UAS, you're frequently dealing with different materials, with different dielectric constants and other characteristics. And you're also dealing with something that tends to be kind of spidery. You know, look at a quadcopter. There's not a lot of mass there, right? There's horizontal extent of these arms that the rotors are on, and not a lot of mass in between. And obviously they're also physically a lot smaller. So you're dealing with a different RF channel that needs to be characterized. What else can we do? There are standardized command and control data links being developed for UAS. And there's a lot of development and testing work that needs to be done there. Then also, we've talked about the dichotomy of using GNU radio for prototyping and development versus using it for actual implementation. Here's a case where you might actually use it in actual implementation. If you're trying to do some kind of a special purpose link, not a generic air-ground or air-air data link. For instance, right now, video. Anybody here done FPV drone racing? Couple of hands, good. So those links tend to be analog, believe it or not. They tend to run at 5 gigahertz, but not to be 5 gigahertz Wi-Fi, rather analog links. And the reason is latency, right? The whole process of digitizing and packetizing and so on adds latency that the FPV racers don't want to incur. And then obviously there's the whole domain of non-communications related RF signals. And I'm sure there's a host of other things that SDRs could be used for that are handy for unmanned aerial systems. The less obvious thing is to turn it around and say, what can you do with an unmanned aerial system for wireless research or for wireless activity? So the first thing that comes to my mind is you can use an unmanned aerial system to put an RF aperture someplace interesting, someplace that previously we couldn't put it. So how about locating sources of interference? Let's say we're in a downtown metropolitan area and we're densely built out with LTE and a particular E node B stops performing well. There's some sort of interferer there. I could conceive of taking a quadcopter and flying it around in the vicinity of that E node B in order to try to localize that interference source. You may need to locate or characterize sources of what I'll call higher layer interactions with systems, you know, as Balint is fond of doing. We could use it also to generate phi-layer interference to RF systems, which is legitimate if what you're doing is testing. And the video that I wanted to show Monday but wasn't able to, just basically that was what it was. It was an LTE signal, and I was watching a tone walk through that signal, and it was a tone that we were intentionally generating so that we could measure our ability to measure the interference. Right? And then and the other thing we can do, of course, is jam. Now, obviously, ever since the Communications Act of 1934 in the United States, jamming has been illegal. But I will lay you odds that if you take a radio-controlled aircraft and you fly it straight at 1600 Pennsylvania Avenue at high speed, probably somebody will jam that thing. Also, we can obviously generate higher layer interactions with systems, and one of the most basic things we can do is use the thing as a comm relay, use it as a surrogate satellite. It's, you know, instead of being 25,000 miles up with all the spherical spreading and loss that entails, it's a few hundred or a few thousand feet up, and so your path loss is a lot lower, although your coverage area is a lot smaller. So here's the standardized data link that's being developed. It's from RTCA. The scope of it is what they're calling ground-based detect and avoid. They used to call it ground-based sense and avoid, and they're going to migrate in the future to airborne detect and avoid, where the two aircraft have conceptually these bubbles around them, these ellipsoids, and if your outer ellipsoid intersects with my outer ellipsoid, then our systems talk to each other and just alert each other to their presence. And then if the next inner ellipsoid intersects, then that means one or the other of us better maneuver. And if the innermost ellipsoids intersect, then there's going to be an inquest. I mean, whether anything crashes or not. Avoidance of mutual interference is what they're focused on initially. They're not even trying to do multi-vendor interoperation to begin with. It's all C-band and L-band, and initially it's all terrestrial, although it's going to SATCOM as well later. And my big beef with it is that they're depending upon the logical link control sublayer for privacy and authentication, and there's no MAC or phi layer anti-jam, which seems to me to present a pretty big vulnerability. Now the spectrum is a total of 117 megahertz of bandwidth. That's chopped up into 5 kilohertz so-called quanta at around 1 gigahertz L-band and around 5 gigahertz C-band, and then an actual channel that will be allocated to a transmitter is some integer multiple of those 5 kilohertz quanta, either 6, 12, 18, or 24 quanta, depending upon the particular class of service. It's just GMSK modulation. It's got simple coding. It's got simple framing. It should be cake to do with GNU radio. So here's one of my FUD slides, fear, uncertainty, and doubt. UASs present a threat to wireless systems. This is some work that was done a little over a year ago and presented, I think at DEF-CON, can't remember. In a merely 18-minute flight, just flying around over one neighborhood in Austin, Texas, they found over 1,600 wireless internet-connected devices, and most of them either did not have any security built into the design to limit access to the device, or they did have security built into the design, but the owner had never turned it on. And people are actually making a business at this point of outfitting UASs to do what might be wireless surveys or might be actual wireless intrusions. So here's an example of what can relatively easily be done. Legality issues aside, this is just technical feasibility. An Edis E312 has got everything a growing boy needs, and it weighs 446 grams. DJI is the biggest seller of commercial and consumer and prosumer UASs. Their latest generation, last time I looked, was the Phantom 4. And after all the good stuff that comes with it out of the box, it's got a residual payload capacity of 462 grams. So we're cutting it rather close there. I've only got, what, 14, I've only got 16 grams for mounting that E312, but I'm sure I can shave a few grams somewhere. So the question that I wish to pose, and I hopefully some of the shills that I planted in the crowd at least will speak up, because I know there are some people in the room who are doing work in the area. How can GNU radio help with at least 4 major issues? How can we safely fly unmanned aerial systems in the National Airspace System? And again, the National Airspace System is that which is controlled by the FAA, like the FCC controls, our spectral system. How do we deal with incompetent flyers, right? This is a similar problem, again, to the discussion with the FCC. I'm a lot more worried about radiation from people who just don't know what the heck they're doing than from people who are malicious. But then there's the handful who actually are malicious. We do have, hostile flyers of these small, cheap craft. And how do we use GNU radio to do other important or cool stuff with UAVs? So that's my set of motivational slides. And so, Nick, are you out there? You're going to talk about balloons, right? Maybe he didn't make it back from last night yet.
Yeah, he looks like a casualty of last night.
All right. Well, anyway, I'm done presenting, and so where's Bob? He said he would say.
Bob is also just in the hallway, I think.
Okay. I'm sure somebody's got an opinion. I'm sure somebody's got one of these things and has been playing with it. There we go, right there.
Hold on. Wait.
Got a mic coming.
Wait, we got to get your mic. Thanks, Jay.
I thought I talked just loud enough already. But so my first thought is, well, great. What you can do is you can force the manufacturers of this Phantom to embed some sort of a beacon in there, and I guarantee that one of the guys in this room within a year will crack into that. So much for that idea. That's my first thought.
Any others? Raj?
So this is kind of it appeared in the news in some North Carolina local place, but there was an old lady who had a couple young teenagers flying UAVs over her property, and it turns out she is a pretty good shot. She goes out and practices her skeet and trap, so she gets her shotgun and she shoots it down. And this is an interesting legal, murky area, but that could maybe answer your question of how you deal with hostile flyers. Use kinetics.
All right.
So yeah, one of the interesting and perhaps unfortunate aspects of this problem is that some of the obvious things that you will want to do are illegal, right? So first off, in the United States, aeronautical mobile service spectrum allocations are few, far between, and already full. So pretty much, if you put an emitter on something that leaves the ground, you broke the law right there. Okay. Second thing is, if you shoot down an aircraft, even if that aircraft is doing something that it really shouldn't be doing, guess what? You broke the law again. okay? It's illegal to shoot down aircraft. I mean, military aside, and it doesn't matter how low it is, right? If that thing is 5 feet off the ground, you would say, obviously my property rights kick in here, right? I mean, I own this 5 acres, and there's my house right in the middle of it, and here's this thing that's 10 feet from my house, and it's 5 feet off the ground. Clearly, it has trespassed on my property. Well, no, actually, it hasn't, okay? If it's off the ground, taint your property rights anymore. Now, there are other laws that may come into play, and I'll make the disclaimer that I'm not a lawyer, right? But you can't really restrict somebody's ability to fly. The FAA owns that power, and you don't get to preempt the FAA. But you can say that this particular thing that you were doing by flying may be a violation of some other code.
Right here.
I had two things now after what you just said. You just said as soon as you fly one of these quadcopters and you transmit, you're breaking the law. So how does not first-person video, why is that even a thing if that's actually illegal?
So that, fortunately, is in one of the few bands that's not specifically allocated for aeronautical mobile, but is allowed to be used with aeronautical mobile. But the one that we all want to use is LTE. LTE we don't get to use.
Okay. I had a second sort of comment / question. It was also sort of maybe germane to some stuff that Pierre was talking about, is why not simply use GNU radio to find who's flying this thing? Because you fly somebody flies something over your property, and there's surveillance issues and there's other stuff. So we've seen how easy it is to make a directional radio. We know the bands are transmitting in. Is that a potential response or a rational response to say, well, you can't shoot them down, but you can go find where they are, you can direct law enforcement to where these guys might be. Is that potentially a solution?
Sure. So are any of you in the room in a position to be able to talk about your work in detecting or locating aerial vehicles using GNU radio or related technologies? Oh, we got a couple of hands.
Does that mean you like a mic? Willing to talk? Yeah. All right. If you could get to Dan, Jose.
Yeah, my name is Jared Dolman. I'm for the Aerospace Corporation. Last year we did have a drone localization project where we had a number of E310s. You know their location through GPS, and you can basically do a TDOA localization of a RC transmitter. It worked pretty well. The transmitters don't have the greatest range, so as long as you surrounded the transmitter with your localization receivers, you could get a pretty good fix.
So another hand right there, I think.
I just wanted to follow the comments, and this is sort of taking it into the RF domain, and we're not doing anything in the context of flying UAVs, but this gentleman just described self-regulation. That's a really, really attractive thing to sort of coattail on Pierre's comments to the FCC. If you can come in with a solution to their problem, they're going to be your best buddy. They're going to support you any way that they can. The thing I was going to make a comment on was what's happening in the 3 gig, and the fact is not everybody's a big fan of spectrum access systems, but ultimately, if we're talking about an application level need, it seems like flying or being able to find bad actors using the same technology would be a pretty useful thing to the commission, and that would get the FAA off their back a little bit too. So be glad to talk about that more in detail if you'd like.
All right, Dan.
So I just joined a small company called Hawkeye 360 late last year, and while we're not focused on drones, we're an RF geolocation company. We're more interested in things on the ground, but but yeah, that's perfectly possible. We're using TDOA, FDOA techniques. Although it's kind of a chicken and the egg scenario where some of the things we want to do, we have to sort of deal with regulatory policy ourselves, right? In order to help the drone situation, we actually have to get through our own regulatory morass.
So talking about using TDOA actually motivates something that we may want to work on in GNU Radio. GNU Radio's relationship with time is still, not completely worked out, especially if you're going to have multiple receivers scattered over a significant geographic area with their interconnections being things that have significant and potentially variable latencies, right? So how do we actually synchronize a collection? We saw, an interesting paper, I forget whether it was yesterday or the day before, on synchronizing receivers when they're, separated by this much and by fixed length piece of wire. How do we do it, over a geographic scope?
National Instruments has an article on doing TDOA on their website.
Eric, is there a mic near him?
I know Khaki has a really neat product called SkyTracker that uses a lot with SDRs and UASs. I don't know if anybody's seen that, but it's really interesting to kind of see what they've publicly released.
I'd also like to add that you can do some of this stuff potentially acoustically. So you can have an array of microphones, and each one of these things probably has a characteristic buzz. So you might be able to track several of them using the similar time difference of arrival techniques, but from an array of microphones. And you could even use GNU Radio to pull that data in and do that signal processing if you wanted to. That'd be an interesting application to see. I haven't seen it yet, and I don't know if anybody's developing it, but it's an idea we've kicked around at the office.
So the point was made that the FPV stuff is in a band that I was saying, well, it's pretty much illegal to radiate as soon as you take off. The spectrum that's actually allocated for aeronautical mobile is broken up into very narrow channels, and they're only usable by real pilots on real aircraft that have real safety concerns, not usable by us kids because we might interfere obviously with the real operational use. But if you're like in the UNI band, that's what's being used by the 5 gigahertz FPV stuff. And there are actually a number of other spectral regions that are being talked about. A lot of people want to use LTE, and I'm a fan. I mean, there's this tremendous infrastructure that we've already built out, and with the use of directional antennas and power control and so on, we ought to be able to get away from the problem of, because you put your emitter up here, it now lit up the frequency in a whole bunch of cell sites, precluding spectral reuse in a substantial area. Hopefully we can deal with that, and maybe that's the sort of problem that our community could attack. There's also people proposing use of 700 megahertz band. There's some 700 megahertz spectrum that got auctioned off a few years ago, and some of the national licensees are promoting that we should go to 700 megahertz for some of this stuff, but currently not actually allocated for that.
Any other comments or questions? We got Jeb.
I was curious if anybody in the UAS community is kind of following all the V2V, V2I, V2P sorts of, you talked about LTE. There's a lot of work in 3GPP going on in that space. Obviously, it dovetails nicely with the D2D stuff I was talking about. Is that a potential option, the 5.9 gigahertz for these vehicles to talk to one another?
Right. There have already been some demonstrations of putting an LTE eNode B on a relatively large UAS. And of course, this would take this down into, for instance, the range extension mode of using D2D, where we don't put a whole eNode B on there, we just put a piece of user equipment on there. But the UAV, with its height of eye, can probably see an eNode B in the fixed infrastructure from a lot further away than a person on the ground. And similarly, the person on the ground can probably see the UAV in an orbit over an area of interest. So yeah, there's definitely some interest on the part of at least the so I live in upstate New York, far, far from the city. And so the Adirondack Mountains, you know, how do you provide emergency services in the Adirondack Mountains? I have literally, just for fun, taken my cell phone to the tops of mountains and reoriented it towards lakes in order to bounce my signal off a lake in order to hit a cell site, right? So there's a lot of interest in putting up aircraft over big open areas like the Adirondacks in order to provide some coverage. I don't know who's going to put money into it. There's interest.
Anyone else? Oh, we got one more? Actually, this has to be our last one. We're out of time.
Just so one other area that it seems like the GNU radio community could kind of contribute in this area would be more on the sort of the security research side in hardening the links and making sure that bad actors on the ground, I guess, aren't able to use the same tools to cause things to fall out of the sky unexpectedly.
Yeah, and so I guess I'll close with just, this is a really important area where I think GNU Radio could make a really significant contribution. So, thank you.
All right, thank you, Stu.